Hello, my name is Garrison Williams. I'm here today to do my Chem 117 experiment, and today I'll be doing a simulation on Beer's Law. So Beer's Law states that absorbance equals molar absorptivity times length of light path times concentration. So what I'm going to be doing here, I'm going to turn this light on. Okay, so what you want to notice is when I increase the concentration, the transmittance goes down. But when I go to absorbance, you want to see when I increase the concentration, it's going up. So concentration is directly proportional to the absorbance. Okay, so when I change the wavelength, notice how the drink mix is red. As I get closer and closer to the red, notice that the absorbance goes down. If I go further away, it begins to increase. I'm going to change the, mixture you'd say, to green. Okay. Now when I go towards green, notice how small the absorbance gets. Pretty much goes down to zero. Not exactly zero, but almost. Also, something we want to look at, I use this ruler here. As I increase the light path, you're going to notice that absorbance also increases. That's also due to the light path, the length of it being directly proportional to the absorbance. Also, I'm going to increase the concentration again, and you'll see that the absorbance rises. As I take it down lower, the absorbance goes smaller. Okay, so I'm going to do one more mixture. Blue, okay? Notice how the light is red, the absorbance is very high. I'm going to go closer to the blue. As I go closer and closer, it gets smaller and smaller. And I'm going to decrease the length of the light path. Not changing much. It's getting smaller and smaller, down to zero. Increase, change it to red or something, give us a better idea. Decrease, getting smaller. Increase, way bigger. Alright, that's a simulation on Beer's Law. Thank you.